Hello students, in this lecture we will study what is meant by polarized light. Also we will study law of Malus. So to begin with, firstly we will talk about wave nature of light. Wave nature of light. Wave nature itself, it means that something is vibrating, something is changing periodically to produce these light waves. We say that light waves are electromagnetic waves. Electromagnetic waves. So there are two things which are vibrating periodically in case of light waves. What is the first thing? It is electric field. And the second is magnetic field. Electric field and magnetic field are varying, are changing periodically to produce electromagnetic waves. Those are light waves. How is the vibration taking place? I will draw firstly, say, magnetic field as shown in the figure. This is the magnetic field which is varying periodically as shown in this figure. See, this is magnetic field which is vibrating periodically. What is the other thing which is varying periodically? It is electric field. So how it is vibrating? Is it vibrating in the same direction? No, it is vibrating perpendicular. It is vibrating in a perpendicular plane. See, magnetic field is vibrating in this plane of the screen, whereas electric field, it vibrates in a plane perpendicular to the screen. So how can I show this? It can be like this. See, this is the electric field E. It is vibrating in perpendicular plane to the screen. So this is the magnetic field, this is the electric field which is vibrating perpendicular to each other, perpendicular to each other. Electric field and magnetic field. So this is the plane of the screen where magnetic field B is vibrating, E is vibrating in this plane, and the direction of propagation is perpendicular to both. This is propagation. This is propagation of light, right? So this electric field vector, when we say that light vector, it is related to this electric field vector. So light vector in this electromagnetic waves, when we say that light vector in electromagnetic waves, we are talking about this electric field vector, right? So this is light vector, which is electric field vector. So this figure shows that electric field is in, say, XY plane. Electric field is in XY plane. Magnetic field is in XZ plane. So this is X, this is Z, and this is Y direction. X, Y, Z, right? So the magnetic field is vibrating in XZ plane. Magnetic field is vibrating in XZ plane, whereas electric field is vibrating in XY plane, and the propagation of light is along x-axis, right, as shown in this figure. So now we will see what is unpolarized light. Light all around us, which are conventional sources of light, which are natural sources of light. Light which we are getting from our conventional sources of light we use in daily life, or it can be sun, natural source of light. The light which is emitted by all these sources, it is unpolarized light. What is meant by unpolarized light? It is ordinary light, unpolarized light. In this light, the direction of E, as I said, E is called as light vector. The direction of light vector, direction of E, is random direction. So, in all possible direction, electric field can vibrate. This is the possible direction. This is the possible direction. So it can vibrate in all possible directions. It can vibrate in all possible directions. This is, we are talking about electric field vector E, right? It can have any direction. So for any direction of electric field, magnetic field will be perpendicular to it. And the direction of propagation is perpendicular to both. So this is the direction of propagation of light. This is the direction of propagation of light. And light vector is vibrating in all possible directions. Light vector means I am talking about electric field vector. So this is the random direction of electric field. And the direction of propagation of light is perpendicular to it. The magnetic field B as well, it vibrates perpendicular to the direction of electric field. इलेक्ट्रिक फील्ड E आणि मॅग्नेटिक फील्ड B हे एकमेकांशी परपेंडिक्युलर डायरेक्शन मध्ये व्हायब्रेट होतात. ऑर्डिनरी लाईट मध्ये, अनपोलराइज्ड लाईट मध्ये इलेक्ट्रिक फील्ड वेक्टर हे कोणतीही रॅन्डम डायरेक्शन असू शकते, त्याला परपेंडिक्युलर मॅग्नेटिक फील्डची डायरेक्शन असणार आहे. म्हणजे सर्व पॉसिबल डायरेक्शन्स मध्ये इलेक्ट्रिक फील्ड वेक्टर आणि मॅग्नेटिक फील्ड वेक्टर व्हायब्रेट होतात आणि या दोघांशी परपेंडिक्युलर असते ही डायरेक्शन ऑफ प्रॉपगेशन ऑफ लाईट. See now, this is unpolarized light, ordinary light. See that all these are possible direction of electric field. So this left hand side, it shows the unpolarized light where electric field is vibrating in all possible directions. These are all possible directions of electric field which are vibrating in all possible direction. This is unpolarized light. This plate is a polarizer. What is meant by polarizer? It is a crystal plate. It is such that it is passing only one vibration out of all these vibrations of electric field vector. Only this vibration in this direction, in the plane of the screen, only this vibration is allowed to pass. So only this one vibration will be allowed to pass. Other all vibrations are cut off here. So this plate, it is called as a polarizer. So this is a polarized light. This light on the left hand side is unpolarized light. This is a polarized light. So what is meant by polarized light? It is a light where electric field is vibrating only along one direction. Only along one direction. Right? So this is a polarized light which is produced when light passes through this polarizing plate. So this polarized light is produced. This is the another plate, say. How this polarizer is passing the light through it? See that only this vibration is allowed to pass vertical direction मध्ये. ही कोणती डायरेक्शन आहे? It is this direction. It is this direction. See that this polarizer has a vertical plane of transmission. What is vertical plane of transmission? This polarizer has vertical plane of transmission. See this word, this is clear from these lines which are in the vertical direction. What does this direction show? This direction shows that it is allowing only these vibrations which are in this direction. Whereas this second plate we have kept here. How is the plane of transmission for this? It shows, see that these are horizontal lines. So this has horizontal plane of transmission. So this polarizer, it is going to allow only horizontal vibrations. Now, are there horizontal vibrations which are incident on this plate? No, only vertical vibrations are there. So there are no any horizontal vibrations which can pass through this polarizer. So here we will get no light, because the vibrations which are produced through this polarizer, which are passed through this polarizer, they will be blocked by this polarizer because it has horizontal plane of transmission. So we will not get any light which is coming out of this polarizer. This light which is passed through this polarizer one, this is called as polarized light, where electric field vibration have no any they don't have any random direction, but they are electric field is vibrating only along one fixed direction. It is polarized light. So let us define polarized light. Plain polarized light. The light which has vibrations only along one single direction, of course perpendicular to the direction of propagation of light, it is called as plane polarized light. So plane polarized light is a light where the light vector is vibrating only along one single direction perpendicular to the direction of propagation of light. So these are the two examples of plane polarized light. In the figure B, how are the vibrations of electric field vector? They are in the plane of the screen. This is the direction. Figure C also shows plane polarized light. But how are the vibrations of electric field vector in this second figure? See, the electric field vector has vibrations perpendicular to the plane of the screen. So both these figures B and C, they show plane polarized light. See here, With a mechanical method, it is tried to explain what is meant by polarized light. See that this is a string. This is a string. It is vibrating in this vertical direction. Further, these vibrations of string are passed through two plates, two sets of slits. This is the first plate where the slit is parallel to the vibration of the string so that the vibrations can pass through the slit. So the string vibrates and it can also pass through this second plate also because the length of the slit is also parallel to the vibrations of the string. So the vibrations of string can pass through this first slit as well as second set of slits and the strings keeps on vibrating. But what happens in the second figure? See that the second plate is rotated through 90° so that these slits become perpendicular to the first one. The first set of slits, it is vertical, second is horizontal. So the strings, vibrations of the strings can pass through the first set of slits, but the second plate will not allow the vibrations to pass through. So the vibrations are blocked here. This string stops vibrating at this plate. So the vibrations along the string beyond this second plate, it is not possible. The same thing happens in case of polarized light. See that this is the source of unpolarized light. This light vector vibrates in all possible directions. Out of all these possible vibrations, which are the vibrations which are passed through this first polarizer, first plate, which is called as a polarizer? So the vertical vibrations are allowed to pass. How is the second plate of polarizer? How is the second polarizer? It also has the vertical plane of transmission. So the vibrations of light vector which are passed through the polarizer, they are also passing through the second polarizer also, and we are getting the light out of this second polarizer. But see here in the second figure, the second second polarizer is rotated through 90°. So the light vector, light vibrations which are passing through this first plate, they are not able to pass through the second plate because now the plane of transmission of the second plate is perpendicular to vibrations. So the vibrations will be blocked at the second plate and we will not get any light which is coming out of this second polarizer. It is polarization of light. Let us define now what is plane of vibration and plane of polarization. Now, this is unpolarized light where electric field is vibrating in all possible directions. If this is passed through this polarizer, if this unpolarized light is passed through this polarizer which has vertical plane of transmission, only these vibrations are allowed to pass. So this is plane polarized light. So what is the plane of vibration then? This is the plane polarized light where vibrations are taking in this plane. So this is plane of vibration. A, B, C, D is a plane of vibration. The plane which is perpendicular to the plane of vibration, it is called as plane of polarization. the plane which is perpendicular to the plane of vibration. So how can I show this plane? It is a plane which is perpendicular to the plane of vibrations. So this is a plane which is plane of polarization. So this is plane of polarization. Say P, Q, R, S is a plane of polarization. So plane of vibration is a plane in which vibrations are taking place, and plane of polarization is a plane which is perpendicular to the plane of vibration. The direction of propagation is this, is the direction of propagation. So to revise with, the figure shows here light waves, that is electromagnetic waves here. This is electric field vector. This is magnetic field vector. They are vibrating perpendicular to each other. These are electromagnetic waves, that is light waves. Whereas here in this figure, out of these two fields, only electric field vector is shown, which is a light vector. So this is a electric field vector, light vector, vibrating in this plane. This is polarized light, where vibrations of light vector, that is electric field vector, they are only on one single plane. So this is the plane where the vibrations are taking place. The direction of propagation is of course perpendicular to the vibrations of plane polarized light. This is unpolarized light, where electric field is vibrating in all possible directions. In all possible directions. So this is unpolarized light. This is symbolic representation of unpolarized light and polarized light. See, this is unpolarized light. This unpolarized light is represented like this. The electric field vector, light vector, vibrating in all possible directions, whereas in polarized light, this is the only direction where the vibrations are taking place. This is unpolarized light. Again, symbolic representation of unpolarized light. The vibrations in this plane of the screen, the vibrations perpendicular to the plane of the screen. So this is also the way by which unpolarized light is represented. These two figures is a symbolic representation of plane polarized light. Here the vibrations are in the plane of the screen. Here the vibrations are perpendicular to the plane of the screen. So this is symbolic representation of polarized light. Polarized light in the plane of the screen. Polarized light with vibrations perpendicular to the plane of the screen. Now let us see what is law of Malus. It is about the intensity of light which is emitted by the analyzer. Now consider this is unpolarized light which is incident on this polarizer with vertical plane of transmission. This is polarizer. So this polarizer is going to allow the vibrations, only those vibrations which are parallel to its plane of transmission. So it will produce plain polarized light. Now suppose this light which is emitted by polarizer is allowed to pass this on the second plate. We will call now the second plate as analyzer. So the light which has vibrations only along one direction, which is plain polarized light. So this light which is incident on the analyzer, is it possible that these vibrations can pass through the analyzer? Yes, the answer is yes, because the vibrations are parallel to the plane of transmission. So these being the vibrations being parallel to the plane of transmission of analyzer, the light will pass through analyzer and we will get here the light which is coming out of analyzer. But now see what we are doing here. This is polarizer. This is going to produce the plain polarized light. But now this second plate which is analyzer, we have rotated it through 90 degree. Now the plane of transmission of this analyzer is perpendicular to this. So these vibrations will not be able to pass through this analyzer. As a result, we will not get light here. No light which is coming out of analyzer. So the intensity of light which is coming out of this analyzer, it depends upon the angle between the plane of analyzer and polarizer. Malus law talks about this. What does this law say? This law says that when completely plane polarized light is incident on the analyzer, then the intensity of light which is emitted by the analyzer is directly proportional to the square of cos of the angle between the transmission axis of the analyzer and polarizer. So let us try to understand this. Now let Im is the intensity of light which is incident on the analyzer. So this intensity is Im. This intensity is Im. And I is the intensity of light which is emitted by the analyzer. So what does this law say? The intensity of light which is emitted by the analyzer is proportional to the square of cosine of the angle between plane of polarizer and analyzer. I is here intensity of light emitted by analyzer. Im is the intensity incident on analyzer. So this law says that I is proportional to cos square theta. I is equal to Im cos square theta, or I upon Im is equal to cos square theta. This is law of Malus. So as we rotate this analyzer, the intensity of light which is emitted by the analyzer is going to change. When these two are parallel to each other, when the angle between these two is 0, then maximum intensity we will be getting. When we are rotating it in a perpendicular direction to the plane of polarizer, then what will be cos theta? Cos theta will be 0. Cos square theta will be 0. So the intensity of, because theta will be 90, then here theta is equal to 90 degree. Here what is the angle between polarizer and analyzer? Theta is equal to 0 degree. So cos square 0 is 1. So I will be equal to Im. All light which is incident on the analyzer will be passed through the analyzer when angle between polarizer and analyzer is 0. When the angle between polarizer and analyzer is 90 degree, when angle between the plane of polarizer and analyzer is 90 degree, then the intensity of light coming out of analyzer is 0, because cos square 90 will be 0. So I will be equal to 0 here. This is about law of Malus. Let us solve the numerical on law of Malus. See here, two polarizing sheets have their polarizing directions parallel so that intensity of light emitted by the analyzer is maximum. What does this sentence say? That the two polarizing sheets, these are the two polarizing sheets, have their directions parallel to each other so that the intensity of light through them is maximum. This is maximum. This is what we get from this first sentence. Two polarizing sheets have their polarizing directions parallel so that the light emitted by the analyzer is maximum. Through what angle this analyzer should be rotated so that the intensity becomes 1/2 of its initial value. So this intensity we want to reduce it to 1/2. Intensity we want to reduce it to 1/2. So by what angle we should rotate it? So how we will solve this? We know that I is equal to Im cos square theta. I upon Im is equal to cos square theta. We want that this intensity should reduce to 1/2 of its initial value. So I upon Im is equal to 1/2. What is given here? I upon Im is equal to 1/2. We want to find out what should be theta. So 1/2 is equal to cos square theta. Cos theta is equal to 1 by root 2. So what is the meaning of this? What should be theta then? Theta will be equal to cos inverse of 1 upon root 2. So you will get two angles. One will be obtuse angle 45 and the other will be 135. We can say that this can be plus minus, this can be plus minus. Plus minus means we can rotate it in the clockwise direction or in the anti-clockwise direction through an angle of 45 or 135. Plus minus means clockwise or anti-clockwise rotation. So we can rotate it in the clockwise direction of 45 or 135, or we can rotate it in the anti-clockwise direction 45, 135. So this is the answer. Plus minus 45 plus minus 135 should be the angle through which analyzer should be rotated to reduce the intensity to 1/2 of its initial value. A similar numerical. Two polarizing sheets have their polarizing directions parallel so that the intensity of light is maximum. Through what angle either must be rotated? Either means one of these two, right? So again I will draw the same diagram. Two polarizing sheets have their directions parallel so that the intensity of light emitted by the analyzer is maximum. Through what angle this polarizer or this analyzer must be rotated so that this intensity becomes 1/3 of the maximum value of intensity. This is maximum value of the intensity when theta is 0. So how we will solve this? We know the formula that I is equal to Im cos square theta. I upon Im is equal to cos square theta. We want to reduce the intensity to 1/3 is equal to cos square theta, which gives cos theta is equal to 1 by root 3. If we see the cos inverse of this 1 by root 3, theta is cos inverse of 1 by root 3. It gives theta is equal to 54.74 degree, of course plus minus or plus minus 125.26 degree. So you can rotate this analyzer through these angles so that the intensity will be reduced to 1/3 of its initial value. So you will be able to solve the numericals with this. Let us solve one more numerical here on Malus law. Two polarizers are arranged such that their intensity is maximum. Through what angle either must be rotated so that the intensity is reduced to 0.75. So in this first, I upon Im is given as 0.75. We want to find out the angle theta between plane of polarizer and analyzer. We have I upon Im is equal to cos square theta, which is 0.75 is equal to cos square theta. 0.75 is nothing but 3 by 4 cos square theta, that is theta is equal to cos inverse of root 3 by 2. So which gives theta is equal to 30 or theta is equal to 150 degree. Plus minus indicates clockwise or anti-clockwise directions. In the second part, it is given that through what angle the analyzer should be rotated so that the intensity is reduced to 25% of the maximum intensity. So 25% means what is given here? I upon Im is equal to 25 upon 100 is equal to 1 by 4. So obviously, how we will solve this? I upon Im is equal to cos square theta as per law of Molus implies cos square theta is equal to 1 by 4, cos theta is equal to 1 by 2. So theta is equal to cos inverse of 1 by 2. That is, theta can be 30 degree or theta can be 150 degree. 30 or 150 degree is the answer. So with this practice, you can solve the numerical on law of Malus. So thank you, students.